Good morning, all of you. Welcome to the another lecture of Atomic Structure and Chemical Bonding, Class 9. Myself, Suman Singh. So, in the last class, we have learned about the Dalton atomic theory. So, now in this class, we will learn about cathode ray experiment or discovery of electrons, right? So, before this experiment, one scientist named William Crook, you can see here, it is written here. So, William Crook is a scientist. What he has done? He has done a simple experiment. And what was his experiment? What he says that when in an ordinary condition, when the gases are in ordinary condition, it will not conduct electricity. Okay, when the gases are in ordinary conditions, it will not conduct electricity. But however, when we are giving a high voltage, or when we are giving high voltage and when we decreasing the pressure, at that time these gases will conduct electricity. Okay, and how we will know that these gases are conducting electricity? At that time we will see a blue light generating from cathode and moving towards the anode. So this was the you can say that experiment conducted by William Crook on the gases. Okay, so this experiment, when Sir J.J. Thomson has seen that experiment, and he tries to know more about this experiment. So what he has done, he has make a same arrangement what this William Crook has done. You can see here, he has made the same arrangement here. So what was his arrangement? You can see there is a tube. You can see there, this is a tube here, and in this tube he has connected this with a very high voltage. As you can see here, he has connected this with a very high voltage. And after that, he has here, it is not given in this picture, he has one put here a vacuum pump also. Okay, vacuum pumps to reduce the pressure. Okay, so when he started to do this experiment, first of all, what he has done, he has supposed at that time, he has given the voltage, suppose 500 volt. Okay, or 5000 volt, right? Like this we can take the example. Or temperature was suppose 10 of Hg. So at that time he has not seen anything in the tube. Inside the tube he has not seen anything. So what he has done, he has simultaneously, he has started to decrease the pressure and increase the voltage. Okay, what he has done, he has simultaneously, he has started decreasing the pressure and increasing the voltage. So when he has increased the voltage about 10,000 volt, about 10,000 volt, when he has increased the voltage about 10,000 volt, and pressure about 0.01 of Hg. Okay, so what he has seen at that time, he shows that a blue light is generating from the cathode and moving towards the anode. A blue light generating from anode and moving towards the cathode. So he called that ray as cathode rays. Okay, so now, since why he called them as a cathode ray, because it is generating from the cathode plate. Okay, as we know that the negative side of the plate is called cathode and the positive side is called anode. Okay, so since this rays was generating from cathode, so he given the name as cathode ray. So now when he saw this blue rays generating from cathode and moving towards the anode, he has tried to do some experiment on this ray. And what we can say, he has tried to learn about this ray, what these rays are and how it is behaving, what these rays are made up of. Like these questions were arised in his mind, so he decided to know more about this rays. So first of all, what he has done, he has put one cross. You can see here cross, right? He has put here one cross. Okay, so when he put one cross here, what he has seen, that he saw a shadow of this cross here. Okay, he saw the shadow of this cross here. So when we see a shadow, suppose we are standing in front of a light, what then if light is directly falling on our body, at that time what we can see, we can see our shadow backside, right? So why we can see the shadow backside? Because this light is coming straight towards your body, right? Or we can say that it is just striking your body. That is why we can see the shadow in this way. Here also this cathode ray is, since it is moving in a straight line, that is why he is seeing the shadow of this cross here, right? So what he concluded, that this ray, since I can see the shadow of this cross behind here, so we concluded that since I can see the shadow of this cross here, then definitely this cathode rays, or we can say that these rays are moving in a straight line. Okay, this he concluded, since he can see the shadow of the cross which is put in the middle of this rays. So he concluded that this cathode ray is moving in a straight line. Now next, this was the first experiment. After this, he has done the second thing. What he has done? He has put one pedal wheel. Pedal wheel we have seen, we can see the example in some market or in the fair. You can say that there is a one this like this substance made up of paper, right? This is made up of paper, and we when we hold this in our hand and when we run, that at that time, with the influence of the air, it will move, right, in this direction or in this direction. Any direction is to move, right? So like this substance, what he has placed, like this substance he has placed here, like this substance he has placed here, you can say he has placed here. So when he placed this substance here, what he shown, what he has seen, that what he has observed, he observed that this pedal wheel are rotating, right? This pedal wheel are rotating like this. Okay, so as we all know that light cannot rotate anything, right? So what he since this pedal wheel is rotating under the influence of this rays, under the influence of this cathode rays, this pedal wheel is rotating, then there must be some material particle in this cathode ray which is striking this, which is get struck, or we can say that which is striking this pedal wheel. That is why this pedal wheel is rotating. Okay, because we know that light cannot rotate any object, right? So there must be some material particle which is just like, we can say like this, this is a pedal wheel, and suppose this is a material particle which is coming and striking this pedal wheel, and this pedal wheel is, because it is striking here, so it is rotating. Okay, so what he concluded, that he concluded that this cathode ray is made up of material particle. Okay, so these two things we have, he has got. First of all, this cathode ray is moving in a straight line, and this cathode ray is made up of material particle. Okay, now next what he has done, to know the charge of this to know the charge of these rays, he has put electric field. You can see here the arrangement. This one is connected to another, this is connected here, and here he has put an electric field here. Okay, as you can see, it is written here, electric field he has put here and here. So in this electric field, this one is positive charge and this one is negative charge. Okay, this one is negative, this one is positive, and this one is negative. Okay, so when he has put this electric field between these rays, what he saw, that these rays are deviated towards the positive side. Okay, these rays are deviated towards the positive side. As you can see here, this ray is deviating like this. So from here, what he concluded, that if this, as the general view, we will see the general view. We all know that positive and negative attract each other, and negative repel each other, or we can say that positive repel each other, right? So since this rays are diverting, or we can say that deviating towards the positive side, since what we can conclude from here, that these rays are negatively charged, that is why it is deviating towards where, positive side, right? If it will be negative, then if then it will not deviate towards positive, right? So since it is negatively charged, that is why it is deviating towards the positive charge, right? So what from here what he concluded that this cathode ray consists of negatively charged particles. Okay, now this was the third, we can say that third postulates of cathode ray experiment. Now next what he says, this cathode ray producing an heating effect, as you can see here, this cathode ray produces an heating effect. How? When we are putting any metal fuel here, whenever we are putting any metal fuel between these rays, and this rays when he strike the thin metal fuel, that metal fuel get heated. Okay, so from here what he concluded that since it is heating the metal fuel which is placed between these rays, so we can conclude that these rays produce a heating effect. Okay, now next, this cathode ray produce X-ray. At that time, when he was doing that experiment, what he shows that this cathode ray, when this cathode ray is striking with a hard metals less like tungsten or molybdenum, etc. You can see here it is written in your book. So whenever this cathode ray is striking the hard metal, as you can see here, hard metals like tungsten and molybdenum, at that time they used to produce X-ray. Okay, so this was the fifth conclusion done by this done by J.J. Thomson. Okay, after that, now what next is what he says, this cathode ray causes fluorescence. Fluorescence means what, we can say that when this cathode ray is striking the glass surface on or the screen coated with the zinc sulfide, produces a fluorescence. Fluorescence means we can say like this, the bright light, it is producing a bright light whenever it is, suppose here you can see when it is striking, suppose it is striking here in this position, suppose, or we can take like this, suppose it is like this, and the ray, suppose it is generating from here and it is going here. So after passing through the anode, when it is striking this here, no, right here, when it is striking, since it is a glass made up of glass, so when it is striking here, at that time it is produces a fluorescence, means it will produce a bright light. Or if suppose we are in place of this, if we are putting here, suppose in place of this, if we have put here a zinc sulfide plate. Okay, or we can say here, if we have put in place of this, we have put here zinc sulfide plate, at that time it will produce a bright light here like this. Okay, bright light it will produce. So what he concluded that this cathode ray causes fluorescence. Okay, after that what, this cathode ray affect the photographic plate. Photographic plate, I hope you have not seen that photographic plate previously in the, when we were using that cameras, and this cameras we were using the negative, we say na, negative, the black one, some of you have seen I think. So that is called photographic plate. Okay, so whenever this rays is striking that photographic plate, it make a hole, or we can say that it will diffuse the spot. You can say, suppose you can I will try to draw here. Suppose this is a photographic plate, suppose. Okay, this is a photographic plate like this, suppose it is a photographic plate. Okay, suppose this is a photographic plate. So this photographic plate, when this cathode ray will strike this photographic plate, it will produce a bright line here. Okay, sorry, it will produce like this. You can take green here. It will produce like this. Okay, it will make a fog here, fogging like appearance. Okay, so this was, he's concluded that this cathode ray affect the photographic plate. Now next, this cathode ray have a penetration effect. How he has noted that this cathode ray has a penetration effect, he put a thin shade of aluminum between this cathode ray. So after some time what he observed that this cathode ray has penetrated this aluminum sheet. Okay, so what he concluded that this cathode ray has a penetration effect. You can take one example here, suppose we have, this is an aluminum plate here, and in this aluminum plate is cathode ray is striking. So after 1 or 2 or 3, after some time, when he has seen that he has penetrated this and cathode ray has come here, okay, like this. He has penetrated and passed here. So he, in this way, he concluded that this cathode ray can penetrate through a thin sheets of aluminum and other metals. So this was all about the cathode ray experiment. So what he concluded that from this experiment he concluded that this cathode ray is made up of material particles, and this cathode ray are negatively charged, and the negatively charged material particle, okay, constituting a cathode ray, he called them electrons. Okay, whatever the material particles which is present in that cathode ray, he given the name as electron, and he told that that electron is a negatively charged. So in this way he has concluded that this cathode ray is negatively charged, and it is made up of material particle, and that material particle he has given the name electrons. Now he tried to find out the charge, exact charge of that particles, or we can say that exact charge of electrons and exact mass of that electron. So to find this exact mass and exact charge of that electron, he now he tried to find out the exact charge and mass of the electrons. So to find out the exact mass or charge of the electron, he at that time he was unable to find out exactly the exact mass and charge of the electron. So what he found was, he found the charge by mass ratio, okay, E by M ratio. He was able to, J.J. Thomson was able to find out the charge to mass ratio of the electron. And so what was the value of that charge to mass ratio? He has find out that the charge by mass ratio of the electron was 1.76 into 10 to the power 11, okay, coulomb per kg. So this was the charge to mass ratio of the electron, which was found, which was discovered, or we can say that which was calculated by J.J. Thomson. So he has given charge by mass ratio. After that, there was a scientist called Melekan. He has done his experiment in Melekan oil drop experiment, which you will learn in class 11. So in that experiment, this Melekan has found out the exact charge of the electrons. So when he has done in Melekan oil experiment, this is not in your syllabus, we will learn this in class 11. So in Melekan oil drop experiment, he has done one experiment, and through that experiment he concluded that the charge of the electron, or we can say the charge of the electron, is what, 1.6 into 10 to the power minus 19 coulomb. He has given the charge that he has given that charged charge on the electron is 1.6 into 10 to the power minus 19 coulomb. Since you can see here, J.J. Thomson has found out E by M ratio, okay, which is 1.76 into 10 to the power 11 coulomb per kg, right? And since from Melekan has found out that the charge, this one he has found out that minus 1.6 into 10 to the power 19 coulomb. So from this data, what he has got here, you can see here, from this data and this data, we can easily find out the mass, right? So by comparing these two data, and by comparing these two data, we have got that the mass of the electron is 9.1 into 10 to the power minus 31 kg, okay. So in this way, what he concluded that the electrons are negatively charged particle and has a charge which is 1.6 into 10 to the power minus 19 coulomb, and the mass from E by M ratio, and by taking this charge here, he has got that the mass is 9.11 into 10 to the power minus 31 kg, or we can say like this, it is approximately 1 by 1837th the mass of the hydrogen atom, okay, mass of the hydrogen. This 9.11 into 10 to the power minus 31 kg is the mass of the electrons of hydrogen, okay. So he concluded that the mass of the electron will be approximately 1 by 1837 of the mass of the hydrogen atom. Okay, mass of the hydrogen atom, which is 9.11 into 10 to the power minus 31 kg. So from here, as you can say, the mass of the electron is approximately what, 1 by 1837 the mass of the hydrogen atom, or 9.11 into 10 to the power minus 31 kg. And the mass of the electrons is so small that it is considered to be negligible, and it is the lightest substance, subatomic particles. Thus an electron may be defined as a subatomic particles which carry 1 unit negative charge, which is 1.6 into 10 to the power minus 19 coulomb, and has a mass 1 by 1837 of that of the hydrogen, which is 9.11 into 10 to the power minus 31 kg, right? So in this way we can, so in this way we have got the mass of electron. So this was all about the characteristics of electrons, which was discovered by J.J. Thomson. So keep up to this. After that, in the next class we will discuss about anode ray or discovery of proton by Goldstein. Okay, till that, thank you.